Hello friends, welcome back to your class 12 mathematics. As we did in the last exercise, we did some introduction on continuity. We did one problem just to get ourselves accustomed with continuity. And today again, with the continuation of continuity, I will be just giving you some theorems in this video, and then in the last, of course, we will solve a very important question also based on these theorems, which will help us get accustomed on what use are these theorems actually for. So I've written down some theorems before we really begin. That is algebra of continuous functions. So the first theorem that comes up is this: if you have two functions f and g on any variable, it can be x and it can be y, it depends on any variable. So if you have two functions f and g be two continuous functions, then first, the addition of two continuous function is also continuous. I hope you get that, f plus g. So the addition of two continuous function is also continuous. Second, subtraction of two continuous functions will also be continuous. Okay, so that means if you have two independent continuous functions, you can add them, result is again a continuous function. You can subtract them, result is again a continuous function. You can multiply them, it will again be a continuous function. You can have their rational in the form of rationals also, maybe like you can divide them also, f by g, that will also be a continuous function, provided of course the function g on whichever variable it may be is not 0, of course. And the fifth one, that is you multiply a continuous function with a constant, that will also be a continuous function. Why? Because in the second theorem, as I've given you here, theorem number 2, it states that every constant function is also, we don't have to prove, if you get a constant function, you don't have to prove that a constant function is continuous. It's a universal fact, no, it's a statement. So every continuous constant function is of course continuous. So if you multiply a function with f, which is already continuous, by a constant, then definitely it's going to be a continuous function. So every constant function is continuous, like constant functions like f of x equal to maybe 4. So this is a continuous function, no problem with that, right? I mean constant function also. Next, the theorem third one, it states, those who have to write down, of course you can write down. So generally continuous function we denote it by f of x is equal to, let's say, like something like c or any other letter which is assumed to be a constant. Then the third theorem states, I'm going to rub this off, I hope you have written it down. You can pause the video and then of course you can write it down, no problem. Okay. Theorem third states the identity function is also continuous. Identity function is also continuous. So how do we denote an identity function? Identity function, if you're dealing with a variable x, that's going to be of course x, where of course for all values of x which belongs to of course real numbers. So if it's y in the variable y, then f of y, the function will correspond to y, of course for all values of y belonging to real numbers. With the variable, it really doesn't depend on the variable, right? So these are 2-3 theorems. There are some more. I'm going to give you all these theorems today in this class, so you can take your pen, paper, and then you can start noting down. I believe I've already done that. The next theorem, it states every polynomial function, I'm not going to prove. If you want the proof, then you can comment on the section below. I can of course definitely prove it for you. Every polynomial function is continuous. Every polynomial function is continuous. Of course, polynomial functions in general, we know how to write down that, so I'm not going to write that. But for example, like f of x, 4x squared plus 2x minus 3. So this is a polynomial function, a quadratic polynomial. So definitely you don't have to prove that it's continuous. Okay, it will be continuous. Alright, similarly, all polynomial functions, it can be of degree 3, 4, 5 also. Okay, theorem 5, that is every rational, every rational function is continuous. That is, like rational functions can be of the form like, numerator by denominator, p of x is equal to q of x. Of course, denominator should not be equal to 0. We all know what happens if denominator turns out to be 0, it becomes undefined, isn't it? So maybe like x squared plus 2 by x minus 1. So you don't have to prove. This is a rational function which is of course or maybe something like x plus 2 divided by x square minus 1. So this is a rational function which will definitely be continuous. Okay, so these are like, you know, universal facts. So if you come across this kind of functions as you are solving continuity, you don't have to prove. So immediately you can just see that, okay, this is a polynomial function, so I don't have to prove that it's continuous. You just have to write on the statement every polynomial function is of course continuous. So that should be enough. You get a rational function. So okay, this is a rational function. It is already continuous, no? In the interval. Then some more theorems. So I think that would be theorem number 1, 2, 3, 4, 5. I guess this would be 6. You can write down the composite of two functions. The composite of two functions. The composite of two functions is continuous. The composite of two functions. The composite of two, of course, like continuous function. The composite of two, not just any function. The composite of two continuous function is also continuous. Now, about continuous composite functions, you have already learned that in the first unit of mathematics here in class 12 in the chapter of functions. I will be also doing that chapter once again, so definitely when the video is uploaded, when it comes out, please go through that if you have any problems on this composite function. It's a very interesting topic, okay, very nice topic also. So the composite of two continuous function is also continuous. So that means if you have two functions f and g which are continuous, then their composite f on g of x, if it's a variable, f of g of x will also be continuous. The result will also be a continuous function. The next, you can so the next theorem, theorem 7. So that's going to be theorem 7. So that will be, okay, the exponential function. The exponential function, I'm going to write it in short here, is also, C means I'm just writing it as continuous, okay? So the exponential function is also continuous. So functions of the form e power x. Then we have theorem 8, which is very, very important. That is the sine function, the cosine function, the tangent function. That is, we all know trigonometry, right? Sine of x, cos of x, tangent of x or tan of x for all values of x belonging to a set of real numbers, of course, will also be continuous. So you get a sine function later on, like sine theta. You don't have to prove it's continuous, it is already continuous. So sine function is also continuous. Then of course lastly we have the, I lost track of the number, the LOGRITHM, the logarithmic function. The logarithmic function is also continuous. That is, the logarithmic function f of x of log of x is also continuous. Okay, so with that, so these are all the theorems. I think maybe around about how many? I guess around about 9-10 of them. So these are all theorems which you have to visualize every time. It should be at the back of your head whenever you do continuity, and then if you can remember that, then it's really going to help you out. Okay, and we will see very soon as we solve more of the exercises. With that, I want to do one example which is going to be very important, and then of course I think it belongs to one of the exercise, one of the question in the textbook also, that is prove that sine of x is continuous. Prove that sine of mod of x is continuous. So here of course we are going to be applying the composite functions. That's why I wanted to do this question. No, it's a simple problem based on the application of the theorems that I just gave you, the algebra of continuous functions. So now, since most of you might be already knowing what are composite functions, so let us just assume that means this is not a single function, isn't it? This is like a combination of two functions. Sine function is on the one side, modulus function on another side. No, we have the sine function on one side, we have this modulus function on one side. So it's like two functions, compressed. One function is inside the other function. So that's what we call a composite function, isn't it? When a function is inside a function, when a function is inside another function, we call that as a composite function, isn't it? So like one ekta upor ekta khali diya laga. So then what we will do is we will try to split them, since we have already recognized. So we will, any function, okay, you can use it as f or g, that's up to you. So I'm going to use this as sin x and the other function as g, that is a modulus function, as the second function. Or let's just let's just take this as the inner one, and let's just take this as the outer one. That's up to you completely, okay? Because as long as we can prove that they are composite functions, then it's not a big deal. So I'll just go for the composite of f and g, that is g on f of x. That will be g on f of x. Let's see whether it works out or not. If it doesn't work out, we'll just reverse the order again, no problem. Definitely it's a composite function, we just have to get the right order, no? Is it g on f or f of g? So only that we have to find out. So g, what is f mod of function? So now, as we know, g of x is sine x. We have to find g of mod x. So that will be sine of mod x. So that will be sine of mod x. We get that. So now we can clearly see that this is a composite function, isn't it? And then of course, there's one more theorem, of course, which I forgot to give you. That is the modulus function. We are going to prove that also. We will be proving that also in the next video. Mod of x is a continuous function. Okay, the modulus function will also be a continuous function. Definitely, of course, we will be proving that very soon in the coming video. So now the conclusion, but for now, for this question. So f and g are both continuous functions. So g on f of x is also continuous, and that is sine of mod x is a continuous function. Is a continuous function. That's it. Okay, so that is what we mean. And then of course, like regarding the composite function, if f and g are continuous functions, then as the theorem suggested, g on f, if it is defined, it depends on the definition, no? So the composite of f and g is also continuous. And then I hope you have not confused, because f and g, composite function of f and g, is written as g of f. So please don't confuse there. Okay, so some of you may be thinking, so why do we have g of f? Because the composite, as per the theorem, composite function of f and g is denoted by g of f. So that's why I'm trying to find out here g of f. Okay, so I hope that you've liked this video. This was basically based on the theorems which I wanted to provide it to all of you, so that in the further videos, now the next 2-3 videos will be based on completely on continuity. That time you'll not be struggling at all. So I'll be eagerly waiting for the next videos. So till then, you can please get accustomed to these theorems. See you in the next video, where we will be solving many problems, many important problems. I hope you've liked this video. Please don't forget to like also. Bye bye.